Hi, all. Any questions before we get started?
Oh, no, no questions.
Hi, Roberto.
Yeah, how's it going?
Good. Let's see. I might as well get started here. Okay. Play in window. Let's see if this works. Share screen. There we go.
Since the universe is a big place, we could easily get lost. So we'll need signposts to give us a sense of scale. The acrobat's ring is 1 meter wide. The crowd is 10 times wider, 10 meters across, larger by 1 power of 10. Now, with every step, every ring, we travel 10 times farther from Venice, and our view of the universe is 10 times wider. The 100-meter ring surrounds St. Mark's, and 1,000 meters, 1 kilometer, the city center. As our speed increases, 4 steps, 4 powers of 10, reveal all the islands of Venice, the Adriatic Sea, and the mainland of northern Italy. Six steps take in Europe from central Germany across Italy to the Balkans. And soon we can see the entire planet, our home, and see is not a star, but an entire galaxy, composed of countless stars. Astronomers have discovered that the galaxies are flying away from one another. The universe is expanding. Our own galaxy and all the others form clusters and superclusters of stupendous size, hundreds of millions of light years across. And here, about 15 billion light years from Venice, we approach the outer limits of the visible universe. What lies beyond this cosmic horizon, we cannot see and do not know.
Okay. Welcome to PY123, Stars and Galaxies. Obviously, this is going to be an unusual semester. This will be new for all of us. And because of that, usually I have things kind of fixed down because I've taught this for years. This is the first time I've taught a full course on Zoom as any other professor here. So we might need to modify things on the way down. Any questions before we get started? Okay, so we've got 115 students registered. I really want you guys to come to these lectures twice a week. You know, I know it's easy to drop off, but really it's important to come because it reinforces what you're learning. The homework is due before the lecture. I did that on purpose. I know it's a little difficult. Usually you listen to the lecture and then you do the homework based on what you heard. Here I do it before the lecture. And the reason I do that is not to punish you guys, but when you hear the lecture, then it will sink in because you've already tried to do the homework based on that. And the material is in the textbook. The homework questions come from the textbook. During these lectures, unfortunately, because there's so many of you, I'm going to ask that you keep your mics off for the most part. We're going to have 60 minutes of lecture because I know we all get kind of tired of Zoom if we go much longer than 60 minutes. And then we'll have 15 minutes of QA. And you can turn your mics on during the QA. During the lecture itself, feel free to put in questions in the chat. I might or might not get to it during the lecture. And if I don't, then I'll get to it during the QA session. So anyway, let's get started. Let me look at the Yeah, definitely. I think group sessions are great. When I teach this in person, I have you guys explicitly break up in groups and stay with that group the whole semester. That's impractical now, but I more than want you to work as a group informally. Also, there's going to be a forum on WebAssign that you can use. So let's get started. First of all, how many of you recognize this picture? Anybody know the story behind this picture? Where it is, who took it? Okay, I see people are using GroupMe. Yeah, that's correct. An NCSU grad, woman astronaut from NCSU. What's her name? Anybody? That's definitely on the ISS. It's on what's known as the cupola, which was put up, I don't know, 10 years ago. I don't recognize that name. Christina Koch, that is correct. And I've been told that that is the correct pronunciation. I'm sorry, Cook. There's so many different, I'm sorry, I think I have it wrong. Anyway, this is Christina Cook. She joined us in 2017 for our 100th anniversary of the department. And this is one of my favorite pictures of her. This is before she went up. She holds the record of the longest time in space for any American woman, by the way. She came down, was it a couple of months ago? Look up on YouTube the picture of her returning to her apartment and having her dog greet her. It's to die for. Okay. So what are we going to cover here? Gain a familiarity with the universe. Become conversant in astronomical technology. When you see articles in the newspaper or magazines, you'll know the terms that they use, recognize concepts, identify certain key astronomical quantities and fundamental physical laws. Every single one of you has had algebra. You couldn't be in this course if you didn't have algebra. There is some mathematics in this course. Not a lot. I don't actually do calculations, but I do ask you to understand the equations and understand proportionality. And I have a page I'll be showing you in a little bit with all the equations you need for this course. And perform basic mathematical equations. There's no calculus in this class. It's just simple algebra, and you guys have all had algebra. And to gain a cosmic perspective. That's my most important goal for this course. Also, we should have fun. This is not a physics course. This is an astronomy course. So there's a lot of material. There is some math. You might think some of it is hard, but overall, I hope you really get a kick out of the course and the material. We'll be studying black holes, galaxies, not so much cosmic strings, but certainly about theories of the universe, and most certainly about dark matter, one of the greatest mysteries of science today. So great mysteries that we'll be covering. Is there life on exoplanets? What are rapid radio pulses? This is brand new in the last year. And we really don't, in fact, there was a discovery just yesterday on rapid radio pulses. What's going on with Betelgeuse? Betelgeuse is if you're familiar with the Orion Nebula, it's the upper left star, which is bright red. It used to be bright. It's no longer bright. Many scientists think it might be going supernova. And if Betelgeuse goes supernova, it will be a spectacular sight. And people wonder, will life end on the planet? Well, we'll get to that later in the course. What is dark matter? What is dark energy? These are the two greatest mysteries in all of science today. Is there a theory of everything? Not yet. And why is the universe? So obviously we're on Zoom for all of the lectures. We will, if you want to ask me questions, do it on chat. I might not be able to get to it during the lecture, but like I said, I'd be glad to get to it during the QA session. We start at 10:15, so at 11:15, I stop talking, and then we'll just have a free-for-all for 15 minutes. We'll be doing polling. Some lectures I don't do any polling. Some lectures, such as today, I'll do a lot of polling. It's just a way of keeping you guys awake and keeping feedback room. I will be, like I said, you need to keep your mics muted during the lecture itself, but feel free to put anything in chat. I kind of hate having to mute y'all, but with 115 students, we just have to. and just to encourage you to attend the lectures, I will be saying things verbally and only verbally that will show up in the lecture, maybe 1 or 2 questions. That way, if you don't attend any of the lectures, you're guaranteed to miss at least a couple of problems on the exam. We will try and use breakout rooms. I didn't have really good success with that last semester, but we'll try that again and see how it works. That'll kind of give us the illusions of working in groups. So office hours, just call me or text me anytime. The Zoom is going to stay the same. I sent you my personal Zoom, but also there's the numbers for the Zoom. Here is the lecture. This is lecture 1. We go through lecture 24. There's 3 exams. The exams are all done in Moodle. We'll get to that in a minute. And then the very last lecture is class presentations, where every one of you, or if you want, you can do this as a group. I don't really care. We'll do a 5-minute presentation, and I'll select the best of those, and we'll just spend the entire 75 minutes having each of you present your class presentation for that. And here are the various chapters. So we have homework not due today, but other than that, there's homework due before every single lecture. And again, the homework material is based on the material is before we cover it in lecture. And all of the information for the homework questions is in the textbook, since the questions come from the textbook. And if you don't have the physical copy of the textbook, don't worry about it, because there's an ebook available through WebAssign. Notice that I numbered the homeworks not at number 1, but at number 2, just to match up with the lecture number. So the first homework due is number 2, which is due before lecture on Thursday. Okay. Homework is 29% of the grade. This is a change from when I teach in person, where homework is a really minor part of your grade, but because we can't really work in groups, where I used to have most of the grade coming from group work, I decided to increase the importance of homework and increase the number of questions in homework. So each homework set is about 20 questions. Please look at it ahead of time. If you do it, you know, Thursday morning, I might not have time to see if you have any questions. Whereas if you do it, you know, a couple of days before, you can email me or text me, or more importantly, go to the forum in WebAssign and ask for help from other students. So I would ask you to go to the student forum in WebAssign first if you have trouble with the homework. And if that doesn't work, just email me or text me. The project, I said, is 4% of the grade. Classroom interactions, 2%. Again, I want to really encourage you to come to these lectures. And one of the way I do that is 2% of your grade is attending these lectures. And I'm kind of experimenting with ways of measuring that. And currently what I say in the syllabus is that I'll measure it if I can see your name in at least 5 lectures during the entire semester. And by see your name, that's in chat. And the reason I have to do it via chat is after the lecture, the chat file is saved, and so I can actually scan the chat file and extract the names. Whereas if you do it verbally, I just don't have any record of it. So in fact, let me bring up the syllabus now. Okay, so stop share there and share syllabus. Okay, so all of you should have a copy of this. It's posted on WebAssign under resources. I also emailed it to you. It's also posted on Moodle. There's the textbook. Here's the schedule. I would encourage you to read this. Okay. I seem to have screwed up, not the first time. So one of these percentages is correct. I'll fix the slide. I think the syllabus is correct. Okay, so homework's gone down to 25%. And I'll update this slide to match it. So let's go by the syllabus. Homework is 25%. The class project's 4%. Classroom interactions 2%. And I measure class interactions with 5 relevant questions or comments via chat. Okay. And then the class project is a 5-minute online presentation with no more than 4 slides. You can work individually or as a group. If you work as a group, just let me know who's a member of that group. Textbook, I really like hard copy, but you don't need the hard copy. You can do it with the online ebook, or if the hard copy hasn't come here yet. And if you wind up getting the earlier edition, the 9th edition, I don't think it's the end of the world. I don't think there's been a lot of changes. So WebAssign homework is due before the lecture. Please use the student form in WebAssign. And then there's details. You get 2 free tries when you do one of the WebAssign homework questions. Each attempt after the first 2 reduces your score by 25%. And there's no extensions in WebAssign. What WebAssign allows you to do is you can extend the homework set by a couple of days, but then you lose 50% of your points. So you might not want to do that often. So the WebAssign also includes a bunch of files. I'll show you that in a minute. The textbook's very good. Do all the homework, attend the class sessions. The exams are going to be in Moodle, and we'll get to that in a minute. So let's stop that. Go back to sharing the file. Keynote. There we go. Okay. So all these lectures will be recorded. This is the location of the recording on YouTube. It's I don't know how to make that any easier. The textbook PowerPoints are at WebAssign resources. In other words, you go to WebAssign, you click on resources, and it will show you the textbook. Now, I made my own PowerPoints, and I will post those after each lecture in WebAssign resources. So right now you have all the PowerPoints from the textbook, and I will post my PowerPoints after each lecture again, under WebAssign resources. I will post an exam guide before the exam, again on WebAssign resources. Classroom lectures are always here. This is another way to get to the Zoom. The exams and the final will be on Moodle. You do it at your leisure. I open Moodle, I think at like 8 a.m. and it closes at midnight. So anytime that day of the exam, you can take the exam. Once you start the exam, you will have 75 minutes or 150 minutes for the final to take the exam. It will include true, false, multiple choice, fill in the blank, ordering questions, and the material will be from the textbook homework and a couple of questions from the classroom presentations. And scan the questions. The homework will always be done through WebAssign. Homework costs $70.50, I believe. You do get a 14-day trial period before you have to pay, but you should all have access to WebAssign now. So Emma says she can't get to the ebook. Keep trying. If that doesn't work, unfortunately, you'll just have to contact WebAssign. It says that. And there are some deals if you have multiple WebAssign courses. So Davis says, I have some weird workaround to be able to access the textbook. Davis, if you get a chance, if you could chat with everybody on that workaround. I don't know. I don't know anything about that. Email or text me. Again, I'd be glad to answer any questions. Just, an hour before a lecture when you're just finishing up the homework, it's probably not the best time. You should contact me early for homework questions or any other questions. I tend to be very responsive, but, I'm not 24/7. What to expect? Goal, obviously, is to learn, get a cosmic perspective, have fun as much as we can in today. The Zooms is 60 minutes. There will be the polls. There'll be some lectures will have lots of polls, some none. The polls, none of them are graded. So they're all just ungraded polls. The QA is 15 minutes via chat. You can do it by audio or via chat and classroom interactions. The class projects, 5 minutes, any topic at all. Please email me the topic as it says in the syllabus by, I think it was October 1st, was it? Anyway, it's in the syllabus. Just to make sure that groups are not working on the same project. And here's the details of WebAssign, which we already went over. And we have a bunch of things that are in WebAssign. Let me just go ahead and show you WebAssign. So, stop. Okay, let's see, open student view. Okay, so this is what you see in WebAssign. You see the various homeworks that are due, and then scroll down. There is the student forum there. And I strongly encourage all of you to use this as the first stop to get questions, because typically fellow students are the best choice for trying to understand the homework questions. It's just because I don't know I don't know why that is. Under resources here is listed all the files I've been talking about. So right now we've got posted all of the PowerPoints from the publisher. Then the formula file, which we'll be talking about in a little bit, is right there, and then the syllabus is right there. And so anything I post to you guys will be posted under under resources. Okay. Math Class Insights, I don't use that, so you're free to play with it, but I don't use it. And then my ebooks is up there, and it should just work. If it doesn't, you'll just have to call website. Huh, that's weird. To my home tab. Oh, that's weird. So to get the ebook to pop up, I had to go to my home tab. Okay, home tab. And then click the view button for the book. Well, that didn't work. My home button is closed top left. Okay, there's the home button. Click and so where's the view button here? Maybe it's here. Okay, so I can't spend a lot of time on this. So, so could you guys email me how you were able to get to this? I'll send a nasty note to WebAssign about this. But yeah, that's clearly a problem. Sorry about that. To be able to open book, use the home button too. Okay, so I'm at home. Should be under my courses and materials. Okay, anyway, whoever can figure this out, send me an email. I'll send a nasty gram to WebAssign when we're done. Okay, stop there. Stop share. And let's go back to Keynote. Okay, sorry about that. Let me make a note to yell at WebAssign. Okay, we talked about this. You get 2 free tries. You lose 25% after each attempt past that. And Resource says a bunch of stuff. Moodle exams. We use Moodle only for exams. There's 3 in-class exams, 1 final. I need to make sure these numbers are correct. Each exam will be about 70 questions and you have 75 minutes. How do you study? Well, review the posted exam guide, which I'll be sending out before each exam. Read the textbook or ebook, review the homework and problems in the textbook. And then, like I said, a couple of questions will be stuff from the presentation itself. there's the formula file, which I showed you there, and here are the files in the formula file. In the formula file, what I've done is tried to put all of the things that are hard to remember in a single place. So here is a diagram of the distance ladder, which we'll be talking about how we measure distances. Distance is one of the most important things that astronomers deal with. A map of electromagnetic radiation going from radio waves, microwaves, infrared, visible, ultraviolet, X-ray, and gamma ray. The Hertzsprung-Russell diagram, which is the most important diagram of all in astronomy. We'll be talking about that ad nauseum. Here's a couple of examples. The periodic table, which is very important to what we do here. And then the 5 dead white guys that we'll be studying here: Copernicus, Galileo, Brahe, Kepler, and Newton. I circled Galileo, Brahe, and Kepler because they were contemporaries. They were all alive at the same time. Whereas Copernicus was early, Newton was late, but you need to know something about each one of these guys. Here's every equation we'll be using in the course. I know y'all love mathematics, right? But rest assured, these are the only equations that we'll be using in the course. Okay. We have two sets of 3 laws: Newton's laws and Kepler's laws that you'll be responsible for. Nebula is kind of complicated, and so I tried to simplify that by talking about the processes for nebula, what types of nebula. There are only 2 types of nebula we talk about in this course: gas nebula and dust nebula. And then there's 3 types of general nebula. In reality, these are all mixed up, but these are the way that in this textbook we talk about: a cold dust cloud, an emission nebula, and a reflection nebula. And those are the only nebulas that you're going to be tested on. There's 4 types of exploding stars, and we're trying to keep it straight with this graphic here. OB, AFG, KM is very important. It's a way that we designate different types of stars, and why it's not A, B, C, D, E, F, G is extremely historical. But anyway, you basically just have to memorize OB, AFG, KM, and there's lots of different mnemonics that we can use. So here's the first quiz, first poll, I'm sorry, not a quiz. Okay. So this is very good. The reason I did this poll is, can anybody tell me why I did this poll? Very good, Jacob. Yes, because the very last line of the syllabus was the name of my dogs. This was just a funny way for me to find out whether you read the syllabus or not. I know it's really easy not to read syllabus because you got 5 classes and everybody sends out a syllabus and they're all multiple pages, but I just, things are so different this semester, I was hoping you read it. And it looks like most of you did, or at least 65 of you did. And that's Cosmo down there, and that's Astro up there. Astro's a little Jack Russell yappy thing, and Cosmo is a beagle that just loves to sleep. He comes after me. Okay. So that's poll number 1. We'll talk a little bit about You Are Made of Star Stuff, which is kind of a fun topic, before we get into our first quiz. Again, the first quiz is not graded. So lots of right as far as it goes, but it's also not correct. Okay, so let's talk about that. So if we take the human body and break it up by biomolecule, we've got proteins and lipids and carbohydrates and mostly water. But, you know, we're physicists, not biologists, so we want to talk about it not at the biomolecule level, but at the atomic level. So here is the periodic chart in a way that you might not be familiar with, and we'll talk about this in future lectures, where the different elements come from. So here is the atoms in your body by weight. So most, if I just weigh you, most of the atoms by weight are oxygen, and then we've got carbon, and then hydrogen 10%, nitrogen, phosphorus, and a bunch of other stuff. This is what makes us up. Oxygen here, periodic table number 8. And just like Neil deGrasse said, exploding massive stars, that's where oxygen comes from. And we'll be talking about that much later in the course. And most of this oxygen is because most of us are made of water, H2O. So, and that's exploding massive stars. Carbon comes from dying low mass stars, such as a star like our star, okay? So again, both of these are from dying stars, oxygen from large stars, carbon from smaller stars. And then we have hydrogen. And hydrogen here, it says Big Bang fusion. Big Bang fusion here is the creation of the universe. The very initial points of the universe, hydrogen and helium were both created as the universe was created. And then we have all the elements here. That's atoms by weight. And so if you look at atoms by weight, we are made of atoms that are created in dying stars, either exploding large stars or dying small stars. That's true. However, if we do it by number, the number of atoms in our body, the vast majority of the atoms in our body are hydrogen. And hydrogen was not created in stars. Hydrogen is primordial. Hydrogen was created when the universe was created. So most of the atoms in your body are hydrogen, and those atoms have been unchanged for 13.7 billion years. So I find that actually more profound. Every hydrogen atom in your body, I can draw a direct line from that atom in your body all the way back to the very beginnings of this universe, and it has not changed in those 13.7 billion years. That I find is amazing and astonishing. As amazing and astonishing that the rest of your body is made up of spilled star guts. Okay. You are star stuff if you look by weight, or you are primordial if you look at it by number. Okay, so those philosophical videos, they're true, but not true. And here's the periodic table for elements. This won't make a lot of sense to you now, but it will when we talk more about the course. We have hydrogen. Most of the universe is hydrogen, a little bit of helium, and then this is everything else. Astronomers tend to call anything other than hydrogen and helium a metal, okay? And so these metals here and here are made in stars, dying stars, either big stars or little stars. Everything above iron is made in supernova explosions themselves or in kilonova, where two neutron stars collide. We'll talk about that. How do we know this? We know this because the entire universe emits electromagnetic radiation. This doesn't look like the sun, but this is the sun. This is the light coming to the sun. We integrate that with our eyes and it looks white to us, but if we were able to look at the spectra of the star in extreme detail, this is exactly what the sun looks like, okay? Here is a blow up of that, and you can see that there's these dark lines in the sun. And those dark lines refer to what the sun is made of. Each one of those dark lines is a barcode for a particular element that's in the sun. Again, we'll be talking about that in great detail. And the different spectra tell us what different things of the universe are made of. We can look at a galaxy that's 13 billion light years away, and I can tell you exactly what it's made of because of these lines. And that's just one of the most miraculous things. There was a statement by a famous physicist in the 1830s who said that one of the things that he knew more than any other thing was we will never, ever know the composition of the heavenly bodies. Just 10 years after he made that statement, we discovered these lines and discovered that, oh, actually, you're wrong. We can discover exactly what those heavenly bodies are made of. So we're going to start a quiz here. Again, this is ungraded. This is through a poll. So let's get started. There's 10 questions in this poll, and there's additional questions in the next polls. Again, this is ungraded. The purpose of this poll is to just make you a little bit anxious and just get you thinking about the sorts of things we'll be covering during this whole semester. Star guts sounds more disturbing than star dust. Yeah, I agree with that. And Art, I don't know what the song is. Sorry. Okay. So I'm not real sure how this works. Are you guys all seeing the poll? Oh, okay. Oh, I only find out when you finish the 10 questions. Ah, good. Great. Yeah. So when you finish the 10 questions, click on submit. Oh, so if you go to the Cengage homepage, let me try that while we're doing this. Okay. Okay, let's see how you guys did. Go ahead and finish up. Okay, stars, oh, sorry, share results. There we go. Stars begin their lives composed primarily of hydrogen. Locations below, the most distant place we have traveled in a spaceship is Ultima Thule. It's now called Eric. I cannot pronounce this for the life of me. This was the asteroid that the New Horizons Pluto flyby flew by just a year or two ago. We've definitely not gotten to Betelgeuse or the Andromeda Galaxy. That would take hundreds of thousands, if not millions of years. What is the following most scientists would say is true of most galaxies? They're moving away from each other. That's good. You guys are doing well. Scientists believe the scientific laws are the same everywhere. They're definitely not different from other parts. the sun is unusual compared to the other stars is it has no companion stars. Most stars in the galaxy, actually in the universe, are married. They have multiple stars. We're unusual in that we have a single star, which is good because otherwise we wouldn't be here. Life couldn't develop. Which of these elements found on the Earth is also found in the sun? True is that's correct. All of the above. Which of the following would scientists say is true about all the matter in the universe? All the present structure was matter in the universe started out very uniform. It's gotten less uniform. Yeah, actually that's true. All the above. All the locations below, the most distant is the Andromeda Galaxy. Each year the sun accumulates more. This looks like a tough one. The correct answer is helium. It starts off with all hydrogen and it burns hydrogen to helium. Hydrogen to helium burning is what it generates most of the energy in the sun. The Big Bang refers to the origin of the universe. Okay, that's poll number 1. Now we'll go to the part 2. So like I said, if one of you can send me an email with exactly how you got to be able to see the ebook, and then I'll send that out to all the students. So this lecture is unusual because I've got lots of polls. Many lectures I'll just have like 2 or 3 polls, and some lectures I don't have any. Yeah, Matt. You'll see lots of typos on the polls, and that's because I can't copy and paste the polls into Zoom. I have to type them manually one by one, which is a real pain. Which is why I'll probably not have a huge number of polls through the course. Polling in Zoom is not a robust feature. So I sat there and typing 40 questions by hand. I didn't stop and correct myself. There's things I love about Zoom and things that could be better. Yeah, definitely the polling is a poor design, but at least I've got it. I'd rather have a poor poll than no polling at all. Now, these questions will not be on the exam 1, but these questions will be littered throughout the whole semester. And the point of me putting these questions up now is just you guys, getting you all thinking about the sorts of stuff that we'll be covering and the sorts of questions you might have in your mind about the universe. Okay, why don't you finish up in the next 15 seconds or so. And again, this is ungraded. 5, 4, 3, 2, 1. Okay, very good. So yeah, so we already have my microwave antenna, microwave telescopes, and we'll talk more about that in a future course. When charged particles move in one direction without changing speed, they give off None of the above. Only if a charged particle changes direction or speed will it emit electromagnetic radiation. According to scientists, where were oxygen, carbon, and iron atoms created? And as you heard in that in the slides before, in the interior of stars. So hydrogen and helium were created in the Big Bang, but everything else was created in the interiors of stars. Our solar system was not formed by the Big Bang. Our solar system actually contains material from other stars. We're like the third or fourth generation of stars. And we'll talk about that when we talk about the sun. Low mass stars actually have the longest life of any stars. In fact, their lives are so long that the universe, we've never had a single low mass star that's died. And so the bigger they are, the harder they fall. So the big stars die very, very young. Small stars live forever. Imagine if that was true with humans. Well, I wouldn't be here. I'm big. When our sun, that's a cute misspelling, isn't it? When our sun was a protostar, it was more luminous than present. It was a protostar, do not produce fusion reactions. We'll talk about that when we talk about star formation. HR diagram classifies stars according to stellar luminosity and spectral class is the correct answer. When our sun dies, it becomes a white dwarf. White dwarfs, a majority of the stars in our galaxy we end up with, correct? And neutron stars are composed entirely of neutrons. Okay. Let me do third one. I'm sorry. What is the answer to 5? Okay, so let's go back to there. 5. The correct answer to 5 is, sorry. Correct answer to 5 is low mass stars are relatively cold in temperature is the correct answer. Sorry. And they're most definitely on the main sequence. So Matt, how did you know the answer to that? Okay. Okay, let's do the third one and then we'll go on to the rest of the lecture. So when I show the poll results, it's only showing what you guys selected, and the red line is the one that got the majority votes. It doesn't show you the correct answer because Zoom doesn't have any way for me to designate the correct answer. So I have to tell you that verbally. So yes, these lectures are recorded and I will post them on YouTube. It takes a day or two to process. I mean, it takes me a day to process it, and that takes YouTube like 24 hours. So, you know, it will take a while for it to be posted, but I will try and post them all. Every once in a while, I get a video that's bounced out of YouTube because of copyright infringement. But if that happens, then I'll post it on my Dropbox and give you the link. Kauth, yeah. I'll have to look up the pronunciation. I mean, I just got to the point where I could understand Ultima Thule, and then they changed the name of it. Irritating. Interesting little factoid, when I used to work at Johns Hopkins Applied Physics Lab, which was a defense lab in outside Baltimore, Maryland. And the office next to mine was working on this project called New Horizons. And the operating room for New Horizons was literally 2 doors down from my office. I wish I would have joined that group. For those of you that don't know, New Horizons was the probe that flew by Pluto in 2014, was it 15? And then went on to fly by Ultima Thule or Arrow Calf, whatever. Okay, finish up, please. Go ahead and submit. 5, 4, 3, 2, 1, 0. Okay. So which of these statements is true about black holes? Only light can escape inside the event horizon. That's false. They are smaller than their Schwarzschild radii. That's true. They do not emit any radiation. Oh, that's kind of false. Yeah, and that's confusing, and we'll talk about that when we talk about black holes. As seen from North Carolina, when will an upright flagpole with no shadow because the sun is directly above overhead? And the answer is never. Our Earth is inclined to the sun at 23.5 degrees, and only 23.5 degrees latitude or below will the sun be directly overhead. It will never be directly overhead in North Carolina. When the moon appears to cover the phase of the sun, the moon, so that's a total solar eclipse, the moon must be in what phase? And the answer is new, not full. It's exactly wrong. How does the speed of radio waves compare to the speed of light? Radio waves are much slower is what people say, but in fact, all electromagnetic radiation travel at the same speed. Astronauts inside the ISS float around as it orbits the Earth because they are falling the same way as the ISS, which is true. And there's no gravity in space is absolutely false. We'll talk about that in a few lectures. Imagine if the Earth was changed to be a perfect circle. How would this affect the Earth? We would still experience, boy, I really didn't proofread this. We would still experience seasons, but the difference would be noticeable. We would still experience seasons, but the difference would be much less notable. We would no longer experience the difference in the seasons. The correct answer is the last one. We would continue to experience seasons in exactly the same way we do now. Where does the sun's energy come from? The combining of light elements into heavy elements is exactly the right answer. That's nuclear fusion. The breaking apart of heavy elements into lighter ones is directly the wrong answer. That's fission. That's the nuclear reactor down the street. That's not what the sun uses. Compare the distance of the moon. How far away is the ISS? Very close to Earth. That's correct. As viewed from our location, the stars of the Big Dipper can be connected with imaginary lines to form distinct outlines. To where would you have to travel to observe a considerable distance in these stars? The correct answer is a distant star. Which following lists the order of closest to most distance? Moon, sun, Pluto, stars is the correct answer. So Matt says, black holes emit gamma ray bursts. actually, Kush, that's not strictly true. A black hole system can emit gamma ray bursts, but they don't come from the black hole itself. They comes from the accreting material that's accreting around it. Matt says, as I recall, technically the radiation in black holes is what amounts to a natural Maxwell's demon. Yeah, so Matt, the statement you said is the statement that Stephen Hawking has said, knowing in fact that what he was saying wasn't strictly true. Really, for the purposes of this course, small black holes do emit radiation, but not from the environment just outside the black hole, and it's called Hawking radiation after Stephen Hawking. We'll be getting into that in a little bit. It's very confusing though, even to astrophysicists. Let's skip the last quiz, and it's almost, the 60 minutes are almost up. I've got 80 more slides. So here are the 80 slides. Okay. And that's the entire course. So did you all get that? Okay, let's go ahead and open it up for any questions. Questions by chat or by Audible if you want. So y'all ready for the final with it? So Kate says she got, I'm sorry, who is it? Matthew said he got it all, yes. Other questions about the course? Ready to go to Astro Worlds. I scared someone. Yes, the slides will be shared. I will put those on the resources under WebAssign. How hard will the final be? We just covered everything. Yeah, the final will be about 150 questions. It'll be on Moodle, like everything else. Astro World, that sounds like a great idea. By the way, I was to the visitor center at Kennedy Space Center. That it's quite a place. You should go. I've been to Kennedy 5 times to see launches of to be invited to launches of various astronomical telescopes. I've been to Kennedy 5 times, invited to Kennedy 5 times for launches. Guess how many launches I've actually seen? 0. Every single time I went down to Kennedy, 5 times, the launch was scrubbed on that day. So, yes, field trip to Astro Curve. During lecture, will you tell us what you were saying is on the exam? Actually, that's a fair thing. Yes, I will. So I will say that a question of what my dog's names are will be on the exam. How's that? Okay. How do you feel about space movies? My favorite space movie is 2001. My next favorite is Interstellar, and I have a personal connection to both of those. In 1997, I and a bunch of other people had a birthday party for Hal. For those of you that have seen the movie 2001, Hal is the computer. And in the movie, they say Hal is born in 1997 in Urbana, Illinois. So I was at the University of Illinois at the time, and in 1997, we decided to have a birthday party for Hal, and we had a great celebration. Roger Ebert was the MC. We had the governor down. We had Arthur C. Clarke was there. Dave was there. And Stanley Kubrick refused to come, but he sent his brother-in-law, who was great. And we just had a great celebration. And then in 2017, the movie Interstellar was playing at the film festival I sponsor in Illinois, and they invited me down to speak about the physics of Interstellar, and that was a lot of fun. I've got a little statue for that. So, Interstellar. Well, it's interesting. For those of you that have seen Interstellar, you definitely should see it. Interstellar was co-written by a guy called Kip Thorne, who won a Nobel Prize partly for the work he did for the movie Interstellar. And all of the physics in Interstellar, he squeezed physics until it screeched, but he didn't actually break physics. And so all the physics you see is absolutely true, except of course for the end where things get a little crazy. So Adrian says, is there a fourth dimension? Well, yes and no. We'll be talking about that when we talk about relativity. There's certainly a fourth dimension when we talk about space-time. But is there a fourth spatial dimension? We have no evidence of that just yet. So Stanley Kubrick moon conspiracy, what is that? And so while I'm waiting for the answer of that, Alex asked, if Betelgeuse exploded in a supernova, what would it look like from Earth? So Betelgeuse is a 750 light years away. And if it exploded, it would be as bright as the moon for about a month. And so it would be incredibly impressive. If Betelgeuse was 50 light years away, it would wipe out life on this planet. So we're really lucky that it's 750 light years away. And so definitely my goal is to blow your mind with this class. So the Stanley Kubrick conspiracy is that Kubrick worked with intelligence to produce the moon videos in the desert, and he makes this message to the audience in the movie The Shining. I had not heard that. Okay, that is wild. Let's see. So the movie Interstellar, the way it ends is not physics. The way it ends is very emotional, but it goes beyond physics, known physics. But Interstellar is about travel through the universe, past black holes, and in the vicinity of black holes. And the graphics done for that movie was the first time ever in history that we really created a visualization of exactly what black holes look like, which was amusing because 2 years after the movie came out, we actually took a photograph of a black hole, which we'll be covering later in this course. And it pretty much matched exactly what we saw in Interstellar. I mean, it's just amazing stuff. Is there evidence for is all the evidence for dark matter gravitational? So there's 7 lines of evidence for dark matter. And in this course, we're going to be covering all 7 of those lines. And at the end of this course, you are convinced that dark matter exists. Right now, we have no idea what it is. We don't know if it's a particle. We don't know if it's a field. We don't know. But what we do know is we've been looking for it for 30 years and we haven't found any. We haven't found squat. And so dark matter, dark energy are the 2 most profound mysteries of the universe. It tells us that we don't know nothing. Back at the end of the 19th century, scientists were saying that they understood the entire universe other than a couple of details with electromagnetic radiation and what they call the ultraviolet catastrophe. The 2 little details, but everything else worked. Well, those 2 little details were the harbingers of relativity and quantum mechanics, which basically said, you think you know physics, you actually don't know anything. And we're at that point now, that before the 1990s, we thought we pretty much understood the universe. And then dark matter and dark energy came along and told us, nah, 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 you know nothing. And so when we talk about dark matter and dark energy, we will be talking about our ignorance, the evidence for this, but not what they are because we don't know. So Sam says, was Einstein wrong? Well, yes and no. We certainly know that his equations could not be complete, and even Einstein knew his equations could not be complete because they didn't play well with quantum mechanics, the other great theory of the physics theory of the 20th century. But he did predict gravitational waves. He did predict the expansion of the universe. I mean, he predicted so many things that I think he and Isaac Newton will go down as the smartest people that have ever existed in the human race. Kubrick was an interesting guy with interesting stories. That's true. I've never met him, but I met a lot of people that worked with him. His wife, his brother-in-law, and some of his associates. He was, and actually I had dinner with Werner Herzog, who, well, that's another story. I've heard Dr. Tyson discuss virtual particles probably being evidence of a fourth spatial dimension. Do you think this could be possible? So there are, for those of you not in the business, there are literally hundreds of theories flying around. And I'm not a particle theorist, so I have no way of judging which one is better or which one is worse. And so my attitude towards all of these theories of the universe is to wait until the dust settles and see who walks away alive. Because if I try and follow all of these hundreds of theories, that's all I spend my time with. And like I said, I'm not a particle theorist, so it's hard to follow. But wait, are dark matter and antimatter the same? Absolutely not. And this is a confusion a lot of people have. Antimatter is normal matter. It just has all the signs flipped. And we've understood antimatter very, very well since the 1930s. What we don't understand is why there's so little antimatter. Dark matter is something completely different. Antimatter interacts violently with normal matter. Dark matter interacts not at all, other than gravitationally. So why is dark matter called Jane? So I learned my, okay, so what is dark matter? So dark matter is a mysterious force that has 10 times more mass than the mass that we see, that gravitationally attracts everything. But we can't see it because it doesn't interact with electromagnetic radiation. So light goes right through it. It is literally dark. We can't see it. There have been multiple questions pertaining to the lab. That's a completely different course. And my name is on it, but it's really the TA that runs that course. And if you have a problem with it, send me an email and I'll direct you to the TA. What is the most famous person you've been able to talk to? That would be Carl Sagan. I was, well, actually, I take it back. Bill Clinton, when he was president. I was able to shake hands with him. I got a picture of it. Long story about that. But other than that, Carl Sagan, I had a great conversation with Carl Sagan. I went up to him and says, Dr. Sagan, it's an honor to meet you. And he says, thank you. Where's the taxi stand? And that was our discussion. And I says, well, I have a question to ask you. And he says, well, if you walk me to the taxi stand, I'll answer your question. So I did. Let's see. After this class, what are some astronomy courses that build off this course material, and another astronomy course to take after this one? Well, so we have 3 basic astronomy classes in NC State. There's this class, and then there's planets, which is PY124, which is a companion class. It covers, actually, I think they use the same textbook. And then, of course, there's the lab class 125. For those of you that have calculus and are interested in a little bit more meat on them bones, we also teach a stellar astrophysics course. I think it's 328. I forget the number. That is, I would strongly encourage you, if you've got calculus, to take the course. There's a lot of things that we can't cover because we can't get into the math here, but with that, astrophysics does. And the universe is written in the language of mathematics. So if you love questions, if you love math, that's the course to take. And what questions do you ask Carl Sagan? Yeah, the one thing that was bothering me with Carl Sagan was, at the time, and this is the mid-1980s, all he talked about was Mars. And I asked him, what's wrong with the moon? The moon's right there. It's a lot easier to get to. And his response was that the moon just cannot inspire people, that you need something that will inspire people. And that's why he thinks that our first stop for a permanent human habitation should be Mars, not the moon. And that was a big debate then. Right now, the answer is neither. Joseph asks, I'm sorry, let me do Abigail. Is it true that Andromeda Galaxy is moving towards us? Absolutely, yes. It will collide with us in 5 billion years, and we'd better be someplace else because it's going to be exciting. I've got a slide on that we'll be talking about. Roberto says there's a black hole at the center of our galaxy. That is absolutely correct. There is a 4 million solar mass black hole at the center of our galaxy. And we'll be talking a lot about that. It's just an amazing. In fact, virtually every galaxy in the universe has a supermassive black hole at its center. What's the most serious threat to life on Earth from outer space? So I'm going to tell you the truth here, and it's going to be a little surprising. So we've done a fairly good job finding the big asteroids. So I'm less concerned. There's certainly a city killer asteroid out there with our name on it, but there's no planet killer asteroids out there with a name on it. So that, you're talking about existential threats. I wouldn't worry about asteroids. And nearby stars, there's no star big enough to destroy us like Betelgeuse. So Betelgeuse was in 50 light years, would be crispy crittered when it blew. And so, but there's no stars like that. Gamma ray bursts headed for us. Again, a gamma ray burst only come from a supermassive stars, and there's really none within a range that could kill us. The thing that would kill life on Earth, or at least destroy our civilization, is a solar superstorm from the sun. And this has happened before. In 1859, it's called the Great Superstorm of 1859. If that storm happened today, it would destroy civilization instantly, because it would destroy all of the power grids around the world. And those power grids would take years to come back. So will we talk about aliens at all? In the very last lecture, we will talk about them briefly. I teach an entire course on aliens at Duke, but that's a different subject. In particular, we'll mention the Fermi paradox briefly. Will collision with Andromeda actually be that violent since the distances are so vast? Well, yeah, I was trying to be dramatic here. When galaxies collide, and they collide all the time, what happens is the gas clouds collide. And when the gas clouds collide, they produce stars, and those stars produce large stars, and those large stars produce supernova. And that happens over millions of years. In general, when galaxies collide, no two stars ever actually collide because the distances are so vast, as you correct. How can we prevent damage to the power grids in events of a solar storm? We can prevent damage to the power grid by shutting down the power grid, which, telling the entire world, oh, by the way, there's a solar storm happening for us. Please shut down your entire power grid. I mean, just doing that would cause trillions of dollars worth of damage. And so there's just not the political will to develop the coordination to do that right now. We would have about an hour's warning. And in that hour, you could certainly shut down the power grid. The storm would hit us, and then we could bring the grid back up, and everything would be fine, other than all the damage caused by the loss of power over those hours. But if we didn't bring down the power grid, then that storm would fry virtually every transformer and every relay on the planet. And that's why it would take years to come back up. Do you think there are different life forms on other planets? The short answer for me is no. And I've got an entire lecture devoted to why I think that. Part of that answer has to do with the Fermi paradox. So Google Fermi paradox and you'll see. Does a person in space age at a different rate to someone on Earth? Yes and no. So for instance, Christina Cook, when she, I think it's Cook, when she returned, she was about a millisecond, and I might have the direction wrong, younger than she was when she left. And so the difference is minuscule. When you're talking about aging at different rates, where you're 30 and your identical twin brother is 50, that requires relativistic velocities. And we do not know how to produce anything that can move at that speed with that kind of mass. What would happen to life on Earth if Betelgeuse exploded much closer, at the point where it would kill us all? Well, so we would have a 1-2 hit, although the 1-2 hit would be separated by thousands of years. The first hit is the electromagnetic radiation. The gamma rays, the X-rays, they would basically destroy, sweep away the Earth's atmosphere, and that would be not good for our long-term survival. And then 1,000 years later, the material from that supernova explosion would sweep by the Earth and then put the finishing touches on it. So what about the age difference in Interstellar? Is that possible? Since Interstellar was co-written by a Nobel Prize winning physicist, the answer is yes, it is possible if you happen to have flown to a planet that is in that particular orbit around a black hole. So yes, it's possible, but again, we have no clue how we could travel by then. And it looks like I'm out of time. These are great questions. We'll finish them up next time. I will see you all on Thursday. Thank you so much. Bye-bye. Hope you all had a good time.